Bon, ben, bonjour tout le monde, bienvenue. Merci d'être ici pour cette midi de la foresterie qui se déroule exceptionnellement un mercredi. On est très content d'avoir avec nous aujourd'hui le Dr. Christel Kern, qui est ingénieur forestier et silviculturiste, mais aussi intéressé par l'interaction entre la couche de canopée et le sous-bois. So we're very happy to have with us today Christel Kern, Dr. Christel Kern, who is a forester and silviculturist, but she's also interested in the interaction between the overstory and understory and management situations. And her presentation will be given in English. At the end of the presentation, if you have any questions, you feel free to ask them in French. I will translate, or Sophie will translate, and Christel will answer in English. Alors, sans plus tarder, je vais inviter Dr. Kern à présenter. So, the table is yours.
Okay. Well, thank you so much for spending your lunch hour with me today. This, I will admit, is the farthest north I've ever been. And I did look up the climate summaries from where I'm from in Wisconsin compared to here, and it looks like our summers are really similar. We have some similar precipitation, but it is the winter lows that are very different. So was it, minus 15 Celsius in Wisconsin and maybe minus 25 Celsius here. So that's where the big difference comes in. So there was some perfectly welcome weather here with the cold temperatures today. So very exciting. So I'm going to be talking about, for today's presentation, sustainable forest management. I did share with some of the students ahead of time some papers that I have at looking at ground layer plants, and I shared that because I'm not going to be talking about that today, but I'm happy to answer questions about it because it's related to the work I'm doing, or if any of you want to meet this afternoon or over lunch, then I'm happy to talk about some of the other research that I do. So sustainable forest management, I'm going to start with that big picture. Here in North America, we've been on this quest for about 100 years or so. In Europe, maybe a few hundred years, maybe in other continents, a little longer. But it's something that we continue as a society to strive for. And this is because the threats to our forests keep changing. The conditions keep changing. Exotic species coming in, fragmentation of our landscape, different uses that the society wants from their forests. So just when we think we have figured out how to meet a specific objective with our forests, something changes, and we have to keep reevaluating. We have to keep being creative. So that's what I'll be talking about, is some ideas and testing these ideas of how to continually meet sustainable forests and all those good uses that we expect from our forests. I'll be focusing on harvest-created structures and how they can affect the forest by using a harvest approach. That means we're extracting commercial products. When we can do this, there's a benefit because it can pay for those treatments for the ecological reasons that we may be managing the forest, as well as the economic reasons. So just for perspective, if you didn't look at the map before you came in, my office is right here in Rylander, Wisconsin. And we're up here, it's about 1,100 kilometers away. And if I would have driven here, it said it was about 12 and a half hours to drive. So during the talk, you're going to hear me talking about the lake states. This is Minnesota, Wisconsin, and Michigan, and our forested areas kind of run here. So this is the region I'll be talking about on the US side, and then I'll be talking about the northern hardwood forest type, which does extend into southern Quebec. So the example problem for today is going to be about managing the northern hardwoods in the lake states. Over the past 100 years, we've seen declines in diversity. And so there's a lot of interest in maintaining the original species composition of these forests. And how can we do that in our managed forests, where we try to manage for multiple objectives, from social objectives, ecological, and economic objectives. In the lake states where I'm from, it's been primarily a single tree selection approach, which means taking out individual trees for specific wood products and maintaining a certain distribution of tree sizes in the residual forest. You could come back and extract trees every 10 or 20 years on a sustainable level. And this type of disturbance creates small canopy gaps. That's what's been happening in my region over the past 100 years, but this type of approach to managing forests is actually really flexible. You don't have to take out individual trees. You could remove trees in clumps to create larger openings and more heterogeneity in that canopy, but in application, it's been very restricted to single tree removals. Well, over the past few decades, there's been different developments in the US on how to address this problem. In the Northeast, so Maine, New Hampshire, Vermont, down to New York, there's been a focus on increasing tree diversity and looking at patch selection. So creating a ½ hectare to 1/2 hectare openings in the forest to allow greater light, more growing space, and allow some of those trees that are intolerant to shade to regenerate and grow in those forests. These forests are predominantly shade tolerant species, so sugar maple and beech. And by opening them with these larger patches, you allow things like yellow birch, cherry, and the oaks to come into the forest. In the lake states, so on the western side in the US, as I mentioned, there's been a single tree selection approach. However, in the past 20 years, they've been adapting the practice to including 20-meter diameter openings with the specific intention of bringing in yellow birch into these. In this area would be largely just sugar maple dominated stands, so dominated by shade tolerant sugar maple. So in the Northeast, these ideas have been in research almost 50 years. They've been in practice about 30 years. In the lake states, this idea has moved into practice in the 1990s with the movement of ecosystem management. And the results on this are just coming out with some of my work and some of the others in the lake states. So just in the last 10 years, these results are starting to come out of research. Another approach would be conserving biological diversity. So not just trees, thinking about the wider range of biota that exist in these ecosystems. And thinking about what is the natural disturbance in these ecosystems. In the lake states, this would be wind disturbances, moderate severity wind disturbances, where they're creating small openings, but also quite large openings, several hectares in size. And these occurring every 100 to 300 years, depending on the stand situation. So this idea would be is you would look at things like this, borrow some of those ideas and integrate them into your silvicultural system. So using a wide range of canopy gaps and so forth to increase tree diversity, but also other biota in the ecosystem. So the research I'll be showing you is going to focus on the tree response to the gaps, to canopy gaps, and specifically looking at gap size. So in the lake states, northern hardwood forests, we had these even-aged forests. So I should mention this was a good learning point for me yesterday during some of the discussions in the meeting I had yesterday, is that the landscape that I'm coming from was cut over around settlement time. So between the 1880s and the 1920s, when Wisconsin, Michigan, and Minnesota were being settled by the influx of Europeans, that landscape was cut over to build cities, to begin farming, settlements, and so forth. Well, farming in these forested regions was not ideal, and the farming settlements were maintained in the more of the plains area, so the southern part of Wisconsin and in Minnesota and Michigan. So these forests have grown up during that time as even-age forests, predominantly sugar maple. And so the idea over the past century has largely been these single tree removals, with the idea that because something like sugar maple is shade tolerant, it can grow into these stands and continue that sustainable process and sustainable management. And then it was more recent in the 1990s when we started thinking more ecologically about forest management to insert larger openings to allow a wider range of species to persist in these managed forests. So this is the working hypothesis in the region. As I mentioned, this research just coming out, but this is the idea that was behind the management. There's also ecological literature to support this type of approach. So the gap partitioning hypothesis comes out of the tropics. These are also closed canopy ecosystems, like the northern hardwoods we would consider a closed canopy ecosystem, a lot of shade tolerant species growing underneath each other and responding to canopy gaps as they're created in the forest. So I'm just going to quickly explain this hypothesis with this conceptual diagram. So it's within gap position. You're moving from the gap edge into the gap center. And this is resource availability from low to high. So this is just theoretical, pretending that we're at the equator looking down on the earth and we're graphing it. So theoretically, as you would move away from the gap edge to a gap center, you're going to have more resources as you move away from those edge trees. As you are closer to the edge, those edge trees are absorbing those resources. If we just theoretically throw in gap size, you could imagine, and we'll just call it a small gap. When you're close to the edge, there's low resource availability. Once you go to the center of a small gap, there's more resources, but it's not very different. And as you increase gap size, you'll have more and more resource availability in the center of the gap. And the largest gap would have the widest diversity of resource conditions. So we also can think about plants and their traits. There's a lot of different traits out there. The example I'm showing here is light. So light is the resource, and the trait is shade tolerance. Plants that are tolerant to shade would respond well and compete best at this low resource position on this y-axis, and the intolerance competing best at high resource positions. So you can see how traits can influence how well. This is one of the assumptions of the hypothesis. And so if you overlay gap size, you can think about composition and diversity with the small gap, having predominantly shade tolerant species. And as you increase gap size, you bring in more plant traits or species. So adjusting gap size based on theory from the ecological literature coming out of the tropics makes sense for something like the northern hardwood forests as well. So this was part of the lens that we use to examine northern hardwood management in the lake states, with some of these ideas of gap size theory, and then using this to look at tree regeneration and diversity. So in northern Wisconsin, we develop a research and management partnership. So I work for the federal government in the US and their research division for the Forest Service. And we also have a management division in the Forest Service. So we come down different pillars, but we work together along the way. So I worked with the local national forest on this, and they're very interested in bringing more species into these stands. The more management they had been doing, the more it was going towards sugar maple, and they're losing these other species. How could they maintain them? So they had a site about 140 hectares in size. It had 13 species on site, so they felt this was a good area because there'd be many seed sources to test some of these ideas. This site was dominated at least 80%, maybe more, by sugar maple. So there is actually probably 90% would be more appropriate. This would be the first cutting in the stand. It was about 60 years old. in 1994 when the study started. The site was considered in terms of its soils to be very good for growing sugar maple. This is a mesic site. So the study treatment is the gap size. For those in forestry, this basal area to begin with was about 31 square meters per hectare. And there was a thin matrix down to 23 meters squared per hectare. There's, within this 140 hectare study area, we have 12 replications of these different treatments. So there's uncut patches that were 0.4 hectares in size, and then we had 5 different gap sizes, 6 meter and 10 meter. And these 2 gap sizes are what you would expect from single tree selection, from the conventional management for these areas. 6 meters is approximately the crown width of a mature sugar maple tree. 20 meters is this gap size. And I apologize, my slides are a little smaller than I was expecting. So if you can't see something, I'll try to remember to read what it says on here. But 20 meters, this is what in the lake states, they began inserting these every hectare in their managed stands to bring in some of those species less tolerant to shade. So they're creating openings theoretically in this size range. And then the larger ones were 30 meter diameter and 46 meter diameter. This you could consider the very lower bound of what they were using in northeastern US for bringing in tree diversity. With some of the work of natural disturbance in the Lake States area, a moderate severity blowdown, when they looked at some studies, they create openings in this zone, the 6 to 10, about 25%. Are created after one of those wind events. This was another 25%, and the remaining were quite large. So 46 meters you consider is a very lower bound, but some of these were multiple hectares in size. So just so you get a sense of how these openings compare to a managed forest or to a natural disturbance. So we set up plots on transects running north, south, east, west. There's about 1,100 plots on site. So it is not a minor task to remeasure this. There were deer exclosures set up. Deer populations can be quite high in the lake states, so we knew this could be a factor. They were only maintained though for the first few years of the study. So we collected information on tree regeneration and other woody plants and herbaceous plants. And we did this 4 times over 12 years. We actually did remeasure this site this summer. It's year 24, but we're still entering data, so I didn't have enough time to share with you another decade of information. So we'll look at some of the results for tree recruitment first. In these forests, natural regeneration is what we expect. This is why people like managing this forest type, because they don't have to pay to plant trees to get another forest to come. It comes naturally. So what I have here is in each row is a size class. So this is 0.5 meters tall, so very small. We'll call them germinants. In this row is 0.15 to 0.6 meters tall, so about knee high, and then greater than 0.6 meters tall, so saplings, germinants, seedlings, saplings. On my y-axis, I have year of the study, so it's time over those first 12 years. And then density, number of stems per meter square, and then the gap sizes are different symbols. So for the germinants, their maximum numbers occurred right after harvest in year 12, or excuse me, in year 2. Statistically, the reference areas, the 6 and the 10 meter gaps, were statistically different. It happened to be a really good seed year for sugar maple. And because we didn't cut in those reference areas, there's a lot of seed source. So we also saw a high influx of germinants in year 12 in the reference area. For the seedlings, their highest numbers occurred in year 6, and statistically they were the highest in the 6 and the 10, much higher than the other gap sizes. Year 12, same pattern with the small gaps having the highest density. You can see the movement of that initial cohort growing up over time. What was interesting though is the year 12 numbers for trees that were greater than knee high, those saplings, were much lower than we expected after 12 years. So just let's look at year 12 a little bit closer. Each row still means germinant seedling saplings. This time, gap size is on the x-axis, so increasing gap size starting at the reference, and it's still density. And this time I'm not only showing you trees, but also shrubs. So shrubs is the dark symbol. When we look at in year 12, 12 years after harvest, as you increase gap size, you increase the number of shrubs. As you increase gap size, we saw the reverse relationship with trees. So there is an opposite pattern between trees and the shrubs. When we looked at seedlings, same thing. Saplings, again, the same pattern. This is suggesting that these shrubs, the germinants are still coming in these larger gap sizes, suggesting they're going to dominate these larger gaps for, and I can tell you, another 12 years to come. So we're still seeing raspberry patches. That's the most dominant shrub in these areas, still persisting and dominating in these larger gaps. So from a forester's point of view, those large gaps were failures, regeneration failures, and the smaller gaps would be considered successes. The larger gaps had these persistent berry patches, as well as other shrubs coming in. My colleague, Terry Strong, who's now retired, he had some microclimatic equipment set up in some of these gaps. He found extreme temperatures. Let's see, I think it was 46 degrees Celsius at 0.1 meters off the ground in some of these large gaps, so very lethal temperatures for seedlings right after harvest. We also noticed more frost pockets occurring. So we just had extreme microclimatic events that were not suitable for getting in that new cohort of trees. We don't have any data on this, but there's possibilities of compaction from the equipment. We preferred and asked the operators to not drive into these gaps and to pull everything out and then process them. But there's a lot of rules that we can't control on everything with some of the contracts. So there was some operations in there that could have also influenced and affected what we're seeing today. Let's look at species richness of the trees. So this is the same pattern, germinant seedling saplings, and time is on the X. In terms of the germinants, their diversity there was no statistical differences. They're really similar over time, not much change. For the seedlings, it was year 6. There was the small gaps were statistically different than the larger gaps. And the same pattern in those saplings, anything taller than knee high. Well, ecologically speaking, we're only talking about a change of one species. So no matter what gap size it was, we moved from 1.8 to 2.8 species. So it's still quite low in terms of richness in these areas. But let's look at what exactly that was. So this is just year 12. This is density is on the Y, it's number of stems per hectare. And now I've placed the 3 size classes on the X, so the germinants, the seedlings, the saplings, and these are going to be stacked bars. So in the reference area, these were dominated by sugar maple, indicated by the white bars. When we look at the larger gaps, again, primarily sugar maple, a little bit of white ash, and ironwood and other trees coming into this. And then we look at the smaller gaps. There's more trees here, I already showed you that data. A little more diversity coming into these smaller gaps. So as I mentioned, the working hypothesis was that this actually would be the most diverse gap size. And what we found was it was the smaller ones that were able to maintain some of these less tolerant species like white ash. So increasing gap size did not necessarily mean greater diversity for these. In fact, gap size really had a minimal impact. There's other things affecting what was happening in these gaps. It could be the site quality was too high and too, it's a good site for growing sugar maples, so they have a competitive advantage here. The shrub interference of getting established before the trees. There's a study that just came out of Michigan in the US, and it looks at some of these patches at a different site. And if those trees don't get established right away when the raspberry is getting established, they don't have a chance. If the raspberry comes in first and then trees try to seed in, it's a barrier for decades. If they're in at the same time, the trees can eventually outgrow the raspberry. Also, right after harvest in the 90s, our region experienced some droughts, which could have affected some of this. And also, I already mentioned the deer as a possible issue. In terms of this conceptual idea, this hypothesis, it looked more like this for this site. So the shrubs were filling in this niche on this conceptual diagram instead of what we hoped we would see after all this intellectual thought. All right, let's look at the planted trees. So right now, for northern hardwoods, it's not operational to be planting, although I'll say I'm hearing more about it, doing it not in a full regenerate the forest sense, but in specific planting, maybe specifically in some canopy gaps. So they're smaller efforts, usually for diversity or habitat reasons. Our main point to include the planted trees was to make sure we had some of these special trees that would diversify the forest available to study their growth and their survival to these different gap sizes, because as we saw from the natural regeneration, we didn't have enough of a sample size to study things like the oak and the birch. So it's yellow birch, red oak, white pine, and hemlock. Those were the 4 species experimentally planted on site. This is survival, is on the Y. I have gap size in the rainbow of codes, and so yellow birch, red oak, white pine, and hemlock. Statistically speaking, gap size was significant, and it was a quadratic effect. Really simply, that means as you increase gap size, you go from the 0 to the 46, it's an arched response, meaning highest survival was in the middle gap sizes. So this could mean in the 0, in the reference areas, there was not enough resources, so survival was low. On the opposite end, in those larger gaps, maybe the microclimate, those high heat and the frost that occurred here was detrimental, so that middle gap size was moderated enough for survival. Statistically, height was important, was significant for gap size. It was a linear model. Really simply, that just means the larger the gap size, the taller the tree. There's more growth, the more canopy openness that they had. But stepping back, biologically, ecologically, thinking about this, not many of the trees survived after 12 years. Less than 30%, very low survival. The trees, they're less than 1 meter tall. Only 5% of the white pine were above 1.3 meters after 12 years. So in a sense, again, this was a failure. although we got some interesting growth responses, if this was something they wanted to do, managers want to do operationally, this there's some other factors involved. So this is myself in year 12, and you can see there's raspberry right here, and there's blackberry shooting over my head. And I had to wear safety glasses because it was so thick, and I had to swim through to find these trees for measurements. So I have gap size on the X, raspberry cover on the Y, and this is the different growing seasons, 1, 4, and 12. So you can see the raspberry fluctuates, but it's high. The larger the gap, the more raspberry. And when you compare the largest gap to the smallest gap, they're still very different in terms of how much raspberry they had in them in year 12. When we had included raspberry in the statistical models, we saw shorter survival. So the more raspberry, the lower the survival of the tree. This maybe isn't exactly what the deer look like in our area, but there were a lot of deer. As you can see, 7 deer per kilometer squared over this study time. And for this range right here, 3 to 12 deer per square kilometer, the maximum occurred right after harvest. We did have those deer exposures, and when we included that in the models, the trees were taller for the ones that were included. When I showed you the natural regeneration data, it was a little bit more messy to look at the natural regeneration because the deer exposures were only maintained for those first few years. So it's easier to detect with these experimental plantings that we did. We had appropriate sample sizes to look at that. So deer and raspberry were some of the factors affecting growth and survival. As I mentioned earlier, we did get some information suggesting that these medium, those 20-meter diameter gaps, could be good for planting these species if a manager considers some of the other factors on site, such as, is shrub competition going to be a problem? Are deer populations high in this area, etc. So some of the take-homes from this study, some of the patterns we saw included increasing gap size led to more shrubs on site. Increasing gap size led to less natural tree regeneration. Increasing gap size resulted in the medium gap size being a trade-off for growth and survival that has potential for some of the species that we're interested in to maintain in these types of forests. In terms of that larger example problem that I've been talking about in the loss of diversity, does the working hypothesis work? This idea of using single tree removals and including gaps or groups. And there could be some unintended outcomes. And so as this research has been coming out, which has been interesting, is that managers have been reaching out to me at the same time saying, you know what, in the 90s, I went to this really cool study site. Whatever happened with that? So I get to share the story and they go, okay, because that's what I'm seeing on my site too. So it's not just the study site that I'm showing you, it's happening other places. Where they have less deer, where it's a little bit lower nutrients in the soil, they're seeing more success. So there is some flexibility with this tool, but for some of the sites where this has been applied, it's going to have some unintended outcomes. What about this idea of looking at natural disturbance and using that wide range of gap sizes? Well, on a site like this, you would create early successional habitat and late successional habitat, and that actually may be an objective in some areas where they're interested in creating wildlife openings. So depending on the objective, there could be some uses of this approach on the types of sites that I've shared with you today. So myself and a number of other folks that have worked on gap studies came together in the last few years, and we did a review because we were each coming up with these studies with a little bit of similar results. And so we wanted to do a kind of a synthesis. So we could share not only our site results, but what we found when we looked across the northern hardwoods from Wisconsin, where I'm at, to Quebec, all the way over to New England. And with that, we came up with suggestions to managers. And I don't need to go through them all here, but for the most part, we wanted to share the message that it's more than just creating those openings, because forest management operations were often very focused on what we can take out commercially and hoping that that is a good solution to move ahead, that it's often that plus many other tools to move that forest where we would like. So some of those ideas just are strategically placing canopy gaps that are created through harvest, thinking about the substrate, other plants. It's not just trees out there. There's other things that are going to respond. And there's more than just plants. There's other biota that are going to respond, and there are tools that we can use to deal with something like deer. And then lastly, to consider planting. So now I'm going to turn the talk a little bit to mounds and tip-up mounds. I'm talking about trees that are uprooted by wind disturbances. A root plate comes up with it. It takes the forest floor. It takes some mineral soil. And these in our region are often created with some of those moderate severity blowdown events. So what role do mounds have in tree recruitment and composition? So mounds are interesting. This isn't a new topic. It's something that's been studied in different places and in North America and around the world. They can provide extended windows for recruitment. So some species, a lot of times light-seeded species, prefer mineral soil. And so these are natural exposures to mineral soil. And because of that very steep slope, plants don't reinvade that space quickly. So there's an extended time for that substrate to be available for tree regeneration. That's different than in these forests, very, litter covered, continuous forest floor substrate. It also provides access to resources. You're just that much higher to accessing light, which is an above ground, one direction resource. It also can provide protection from deer. So some of these mounds can be a meter tall. Some are, gosh, I took a picture this summer in Maine of one. It felt like 4 meters tall. It was quite large. So in terms of, just a physical distance from something like deer, if that's an issue, could provide that. And then along those same lines, in terms of trees trying to compete to that canopy position, they got a head start compared to trees growing off the ground. So this was another research management collaboration. This one I actually work with the state of Wisconsin, so it's like a provincial government, and they are very interested in this topic and integrating some of these ideas where conservation and habitat are the highest priority for some of their state lands. And so we set up a study in northern Wisconsin looking at northern hardwoods in 2013, and we selected stands that had experienced one of these moderate severity wind events around the year 2000. So about 10 to 12 years after this event, we collected some information. We went to these were old growth sites. So these areas, we have some truly old growth sites. They may have had white pine cut out of them around 1900, but for the most part, they were untouched from the settlement area. So they are our best examples of pristine forest for this forest type. And so we are interested to look at areas that were not affected by those storms, and then the affected part, and look at how did the composition and structure, how did the tree regeneration differ, and how did this microtopography and substrate differ between these two conditions. So it was a natural experiment. So for the results, I'm going to show you reference areas are this column, and then the wind, calling it a blowdown. And then the results are the trees being on the mound or off. And then these are different size classes. So everything less than 11.5 centimeters DBH. This would be the small saplings, less than 2.54 centimeters. We'll call these the large saplings, 2.5 to 11.5 centimeters. So statistically, when we looked at tree regeneration, there was more, indicated by the letter A and being higher here, more in the blowdown areas. For the small saplings, same pattern. There was just more in the blowdown areas. And this makes sense, right? The big trees are blown down, there's more light available. Trees, there's space for them to come in. When we got to the larger saplings, we found more in the blowdown, but specifically they were statistically different, higher densities being on the mound within the blowdown areas, suggesting that for all this regen to grow to that larger size class, there's a bottleneck happening off the mounds, and there's an advantage to being on the mound to growing to this larger size. Some of this could be due to the browse. So we found more browsing off the mounds compared to being on a mound, no matter what condition we looked at. Okay, then I'm gonna break it down by species. So this is sugar maple, shade tolerant. It has a larger seed. We found more sugar maple regeneration off mounds compared to on mounds. Yellow birch, this is a small seed, wind-blown. It's less tolerant to shade compared to sugar maple. And we found more of the yellow birch on mounds compared to being off mounds, so on the flat or pit areas. We had a group, we didn't have enough of some of the other species we were interested in, so we lumped them into a larger group. This did include conifers and hardwoods, so things like hemlock are included in here. The aspen, paper birch would be included, and there's a whole list of species that were included in light-seeded species. We were interested in this group because of their wind-blown characteristics. Because on these steep sides, they're more likely to stay on compared to like an acorn from an oak tree, which would just roll down. So they have a greater possibility of invading this type of substrate. And a lot of these species actually would, the light-seeded species would add good diversity to these forests. So for the small saplings, less than 2.5 centimeters DBH, we found the most saplings on the mounds in the blowdown area compared to mounds in the reference area. Part of this is explained by there being this pattern of more browse on the saplings in the reference area. Regardless of what was happening though, we still find this larger size class on mounds regardless of what condition it was. So in summary, the mounds in the region that we're looking in, they're associated with yellow birch, one of the species that we would like to see more of in these ecosystems. And they're also correlated with some of the light-seeded species, which would also add diversity to these forests. There's this interesting niche partitioning of being on the mound or being off the mound, with more sugar maple being off. So allowing coexistence of those species. So that was an interesting finding. And also some of the effects of browse, just less browse on trees that were found on the mounds. And also this was an area where we tended to find some of the larger saplings. One of our interests in this was yellow birch. And we are interested in looking at some of those dynamics of yellow birch to regenerate itself. In that single tree selection forest management in these types of forests, or in areas where there's been minimal disturbance, yellow birch isn't replacing itself. So for example, prior to the storms, there was about 11% of the basal area of the overstory was yellow birch. And when we looked at yellow birch in the undisturbed areas that were not affected, only 2% of the regeneration was yellow birch. When we looked at these blowdown areas, it was 30%. So more likely to replace itself, being at 30% with that goal of getting back to that 11%. So this was a research management application, a joint effort, so we needed to think through does this make sense? So what we found is about 3% of the area was in new mounds created just by that storm. There are lots of old mounds when you're out there. It's like hammock hollow type of pattern on the forest floor. But 3% of them were new. So are those worth maintaining? Do we need to be concerned? Because in a salvage operation after these storms, normally forest operations are just coming in, they're taking out all that commercial value before it's infected with disease or insects, extracting that right away. And for these uprooted trees, when they do that, they're usually still intact roots on one side, and the stump just flips back over. And so you lose that microtopography change for another, 300 or 1,000 years. So is this worth doing something about that? Well, when we looked at our data for that 3% of the landscape, 60% of them were occupied by yellow birch. And based on some other data, looking at salvage operations, it's estimated about half of those newly created mounds are missed. So once I did a bunch of back of the envelope calculations, it turned out you would need to reserve a few per hectare if you assume some are also going to be missed. Talking to my management partners, they thought, you know what, that sounds worth it to us, because we want these species in our forests. We're having a tough time trying to do it just with our regular silviculture tools. And if nature is going to do it for us, and we just saw that most of that yellow birch is coming down in blowdown areas, and it's mostly on these mounds, that they're worth maintaining for the long term. And so I already explained this, but this is what the state of Wisconsin is using in some of their high conservation value forests. Maybe not in their production forests, but in those areas where they're interested in habitat, where that's their main priority. These are ideas that they're applying. Other groups interested in this include the Nature Conservancy in the Lake States. They're working with some of these ideas. And I've also been hearing now from my national forest partners as well that they're interested in trying some of these ideas of not only thinking about salvage operations, but opportunities to create mounds in some of the managed operations. And I didn't get into this because we didn't have a lot of time, but a lot of the other mound research that we found in the literature was in other regions. It was very focused from an ecological perspective, which was good. It provided a lot of background for us, but it was hard to integrate some of those ideas into management. So the unique part of our study was that we included forest inventory methods with the survey of the mounds and the tree regeneration, so we could better connect it and integrate it into practice that way. So in terms of this larger example problem of the northern hardwoods, loss of diversity, there's a lot of tools. We need to be creative, and maybe using these mounds in addition to gap cutting and all these different things are a possible recipe to start working on to increase diversity in these forests. And so that brings me back to where I started at the beginning of sustainable forest management, how we need to keep questioning ourselves. When we think we got the working hypothesis solved, we need to keep coming back and try new ideas. And so that includes me coming from Wisconsin all the way up here to share this information, and hopefully this starts a conversation that goes on and grows into new areas as well. So Thank you, Nicole, for hosting me and arranging everything today. I think that's my next slide. I also want to thank the Forest Service, who sponsored a lot of the research that you saw today, as well as the state of Wisconsin and the many contributors to this research. This wasn't a solo effort. Many, many people contributed to what you saw today. So thank you very much.
Very much, Christel. That was really interesting. Are there any questions?
Well, thanks a lot. It was really interesting presentation. I was wondering, and maybe I missed it, but in the gaps that you created, did you have any soil preparation treatment?
We didn't. In hindsight, that would have been a great treatment.
For yellow birch, it's, well,
yeah,
based on experience here in Témiscamingue, that's the whole thing. You have to do scarification. Is it the same thing in English?
Yep.
That we're still not.
So some of the new studies in the region are including scarification, and so far seeing better success.
Because I have to leave soon. Besides deers, do you have any other species that might browse the young stems, like hares, rabbits, anything
Hare,
else?
yep. So that could have been an issue too.
Yeah, I don't have any solution, but yeah, that's probably another problem for regeneration.
Yeah.
I know you look like you're going to ask.
I'm wondering if cedar was included in any of the mound studies, because I know we have a lot of problem with cedar regeneration because of deer browse largely. So I was just wondering if they were included.
With the mound study, they were lumped into the light seeded species group. We did not see much cedar though. Yeah, so that's some other studies I'm working on, as well as looking at how to integrate regenerating cedar into management practice. And that is a big question in our region. Any other questions?
Yes, I was wondering, are you confident that in the gap openings, all the species you wanted to regenerate, do you think the seeds, they get there? They have seed traps to be sure that they had the opportunity to start? Maybe you just didn't have enough source for, I don't know.
Yeah. No, I think you're right. I think the site was selected because it was diverse, but it wasn't tested for that actual being adequate for appropriate seed source. So Michigan State University has a new study in Michigan, including the scarification. They put out the seed traps, and they're also doing some seeding experiments. So hopefully we can unravel some of these questions with that.
And because the treatments are not that bad, but it's just maybe the seed source is a problem. So yeah.
Right. May have been a poor seed year right after harvest, and then they had no chance later.
Any other questions from the room? Sophie, do you have any questions for that? I know, I have lots of, yeah, I was, I have lots of questions, but I'm going to save them for later. Anybody else? Maybe I have one question that might be of interest for the students. Kind of more generally, you've talked about national forests and state forests. So is most of forestry done in Wisconsin on government-owned forests at some level, or is there a lot of private land as well?
Yeah, good question. So in Wisconsin, and it's very different across the US, it changes. In Wisconsin, I would say maybe about half the land is public land, whether that's federal, state, county. We have 3 levels of government that do forest management. The rest would be private, and that maybe 80% of that is private family or small ownerships.
Okay.
Maybe 20% is industrial forests. So we have a very large portion of small forest landowners.
Must be a challenge in developing sort of landscape level biodiversity targets.
Yep. So usually, like someone like the U.S. Forest Service, the National Forest System, they'll look at their landscape, and then they look at the parcels they own, and sometimes it looks like a quilt. So they're all the green ones, and then the state maybe is the pink ones, and then usually the private ownerships are all gray. but they still analyze that whole landscape when they're thinking about biodiversity. And then they have to make some assumptions about the private lands. Maybe there'll be no change. A lot of the small ownerships aren't interested in managing their forests. So then they'll look at, well, maybe the county's cutting a little heavier because of that. So then we know that's, you know, going to have greater effects versus, and then they kind of factor that whole landscape, even though they don't own it. But it's difficult to do that assessment since they don't have the large ownerships.
It's interesting. It contrasts a lot with our situation here in northern Quebec, but it's more similar to what happens in southern Quebec, where there's a lot of private land ownership.
Okay.
And small lots.
Yep. Yep.
Interesting. We're just about out of time, but if there's anybody with a last question, no, you're saving them for this afternoon. You're coming. So just as a reminder, there is a discussion group for the students this afternoon in room E210, so in our corridor there, at 2 o'clock. Tu te rappelles, il y a une discussion avec les étudiants à E210 à 2 heures. Je vous invite tout le monde à venir qui sont intéressés, particularly the people in my lab who work with plants. Puis avec ça, je vais vous laisser. On va avoir 2 autres midis de la foresterie en décembre. Le début décembre puis milieu de décembre, on va vous revenir avec plus de dates et détails dans quelques semaines. Alors, merci beaucoup.
Thank you.